more on like 1.4 onwards, and then get to 1.1 and 1.3 after if we can.
Alrighty.
Is that correct? Yeah, 1.1.
So you're gonna do 1.4 onwards. Okay, gotcha. 1.6 is transformation, which we kind of did last year. I'm not sure if you remember.
Yeah, and the only thing we need from 1.5 are inverse functions. That's the only thing I need to study from 1.5.
Okay, not parametric.
No.
All right, that's good. That's good. All right, let's quickly get this inverse thing over with, because the idea is very simple.
This is 1.5, right?
Yeah, this is 1.5. Yes, correct.
Okay. Yeah.
So an inverse is a function, okay?
Yep.
You've heard of reflection on the y-axis, reflection on the x-axis. But to get the inverse, you have to reflect it about this line. And this is the linear function, y equals x, the parent function. So the inverse of anything, okay, graphically, all you have to do is flip it about this axis. Imagine there's a mirror here, and we're going to see where about it's going to go. Okay, here, let me do this part by part. Look at the top part, right?
Mm-hmm.
If you have a mirror here, and if this is going like this, how's the other part going to look? Like that.
Yeah. Okay.
So there's the 1/2 of this. Now let's look at the other part. There's a mirror there, and if it's going like this, then it's probably going to go like this. Yeah.
Yep.
And then there's the second part. And there we go. The inverse of this is y equals x squared. Quadratic, the inverse of that is y equals plus minus the square root of x. The top function here is square root of x positive, and the bottom function is the square root of x function reflected on the x-axis.
Okay. I don't think we went over anything like this in class. I think she wants us to be able to do it algebraically rather than graphically.
All right, let's do it algebraically. So you have y equals x squared. Okay. Step 1, you need to flip the y and the x. Y becomes x and x becomes y.
Okay.
So you have so y becomes x and then x becomes y. You write it like that. And then what does this equation become?
X equals y squared.
Yeah, exactly. X equals y squared. And then step 2 is to solve for the new y.
Yeah.
Solve for new y, which is your f inverse, or the inverse function.
So we're not allowed calculators either.
Yeah, that's fine. We don't need a calculator.
Yeah. More f inverse. Okay. Yep.
Okay, so the next step, how do we solve this for y?
We plug in y values.
No, we're trying to isolate for y. We're trying to solve for new y. We're not going to plug any values in here.
So it would be root x equals y.
Plus minus root x equals y. Square root of anything is plus minus.
Okay. Okay, so how we would solve that is just...
No, we don't need to solve it. We're looking for the equation. See, we're looking for this, and we got that algebraically there.
Okay.
Okay, so that's how you would find it algebraically.
Yeah. So square root of anything is plus minus?
Yes. So square root of 4 is plus minus 2.
Oh, shit.
Okay. Because plus 2 squared is a 4, right? That's fine. But then minus 2 squared is also a 4. So that means the square root of 4 is plus and minus 2.
So that's if they asked you. Okay. Okay, I get it.
And to determine whether something has a function or not, right? See, there's the first question here. To determine if something has functions or not, so you know this one, vertical line test determines whether this is a function or not, right?
Mhm.
Vertical line test determines whether f of x is a function, but now there's something else. This is called the horizontal line test. So horizontal line test tells you whether f inverse of x, the inverse of this, is a function or not. So if you do a horizontal line test here, it looks like this. See, it crosses the graph twice, once here and once here, horizontally.
Mhm.
That means f inverse of x for this guy is not a function. And we knew that because the inverse of that is this, plus square root of x.
That would fail vertical.
Yeah.
Yeah.
It's going to fail vertical line test, but this is given to you by the horizontal line test on the main function.
Okay. She said she recommended going through. There's like review at the end of the book.
At the end of the book,
Yeah, she said, or at the end of each chapter, I think. Sorry, not the end of the book. So there should be like a review test. She said she recommended we go through it.
is this the one? Review exercises? It's not called a test, but I think.
Yeah. Sorry, she didn't say a test. I added that, but review. Yeah, I think it should be this one.
Yeah, I think it is this one. Alrighty, let's jump into this. So this has to do with the 12 different functions or whatever.
Yeah, so this is 1.1.
I'm not sure where the 12 different things are. That's what this is, I think.
I think they're 1.1. Yeah.
Doesn't really matter, right? Let's just do them. So it's relevant to your test.
Mhm. Okay, so that one is a squared, or
Yeah, I know what's gonna happen to the squared function.
it's gonna go down 1 unit.
Yeah, exactly. So this is the squared function, parent function. So this is gonna be going 1 unit down. So it's gonna look something like this. At -1 is the vertex.
Yeah, and then next one's also a squared function,
Mhm.
but it's going right 2 units.
Yeah, good, perfect. So it's gonna look like this. The vertex would be at 2, 0.
Mhm.
Okay, what about this one?
And this one is a radical,
Which one are we looking at?
E,
E is not a radical. Radical is means a square root.
or sorry, what reciprocal? I always get this mixed up.
It is also not a reciprocal.
Really?
Reciprocal relies x to be in the denominator. The variable is going to be in the denominator. Here it's in the numerator.
So this is just linear then?
It's just linear, exactly. So the slope of this, you can rewrite that as 1 over 2x minus 1 over 2. Just distribute the x's. So this is a linear function with a positive slope and then a y-intercept at -1 over 2. So just a straight line that goes through -1 over 2.
Wait, what? Okay. 1 over 2 and 1 over 2 down? Is that what it means?
No. It means the slope, right? Linear is in the form of mx plus b. So
Yeah.
the b is -1 over 2. This is the y-intercept.
Mm-hmm.
And then the 1 over 2 is the slope.
Oh.
Rise over run is 1 over 2.
Linear. Mx plus b. Okay. Yeah.
Okay, that's simple. It's a linear. It's a straight line. This one.
Yeah. G is absolute value.
Mm-hmm.
And it's 2 units to the right, or to the left, sorry.
2 units to the left, exactly. The parent function is a v at the origin. So this is going to be a v at 2 units left at -2, 0.
And e to the x is, isn't that exponential?
It's not exponential? Is that what you said? Or?
No, isn't that the exponential function?
Correct. What does the -1 do?
Down 1 unit.
Yeah, exactly. So our parent function looks like this.
Yeah, it goes up like that. Yeah.
So now at -1, there's an asymptote, okay? And our final, this guy is just going to look like this. It's not going to cross that. By the way, the domain for all of these guys, for everything we've done so far, the domain is
Negative,
XCR.
positive.
Yeah, exactly. Let's say same thing. Negative infinity.
All real numbers, yeah.
Yeah. Well, now let's just briefly talk about the range. What will be the range here?
The range would be -1 to positive infinity.
And what about C?
It would be positive, or it would be negative infinity to positive infinity.
No, not the range, the domain. What about the range? So x minus 2 squared looks like this. It goes 2 units to the right. It's a quadratic like that. So what's the range of this
then it
function?
would still be 0 to positive infinity.
Yeah. What about E?
E would be,
So it's a linear function, looks like that.
it would just be negative to positive
Yeah.
infinity.
G?
G would be the third to the left 2 units, and it would just be 0 to positive infinity.
Good. Now let's look at I. So now the asymptote, right? For the parent function, the asymptote is this one at origin, but now it's at -1 on the Y. So what's the range of this? The domain is XCR.
-1 to positive infinity.
Yeah. Is the
But
-1
not
inclusive?
inclusive.
Yeah, good.
No.
Yeah. That's the range of this transform function. Okay?
Yeah.
These are the same. Let's just do H and J from here to save some time because the rest of them are similar. Let's
Okay.
look at H.
There's a reflection over the horizontal.
Yeah, exactly. Over the x-axis, a sign would look like this. Okay. That looks like that. But now this guy would look like this. Like that. Because this has been reflected on the x-axis.
Yeah. Okay. So wait, sine starts at
0, 0.
maximum.
No. Sine starts at
0.
the equation of axis at the middle, not max, not min, in the middle.
Okay. And then cos starts at what? A maximum or minimum?
Yeah, positive cos starts at maximum, negative cos starts at minimum.
Okay. Got it.
Now H, what's the domain and range of H?
Domain is just going to be negative to positive infinity.
Yeah. What about the range?
And the range is going to be -1 to +1.
Inclusive or not?
No.
The negative ones, and no, they are inclusive. The only one that's exclusive is the exponential function.
Okay.
And then for the logistical function, it's
Oh,
also
logistical.
yeah, that's also exclusive. So exclusive. So whatever the asymptote here, it won't touch that.
Yeah.
For both of these, okay? And then you have the reciprocal function, and this is the only one where x cannot be something.
Yeah. Okay. So, okay. Reciprocal. There's always something that x can't be in reciprocal.
Yeah, there's always something that x can't be and y can't be. It can be anything else except for something. Like here, we can do a quick example. 1 over x minus 3 plus 8, okay? That means
1 over x minus 3 plus 8. Okay.
Tell me what x can be.
It's 3 units to the left, or 3 units to the right, and up 8 units. Okay. X can't be. How would you graph that?
Okay, so you graph it like this. So this is the parent function, looks like that. Yeah.
Yeah.
So for the parent function, there is an asymptote. There's 2 asymptotes, one on the y-axis and one on the x-axis. Okay. So now this has gone 3 units to the right. X minus 3, just like it means here. It's gone 3 units to the right and then 8 units up. Okay.
Yep.
So your graph would look like this. It's gone 3 units to the right. So your new asymptote before it was at 0. Now it's going to be at 3. And your new horizontal asymptote is at positive 8. So your graph would look like this.
Okay, so the domain, you'd have to use union here. Okay, the domain would be positive to negative infinity?
No, negative infinity to 3 exclusive. Union 3 to positive infinity. It cannot be 3. You see, if x is 3, then you get a 0 in the denominator.
Oh, yeah.
Very similar, right? Very similar. For exponential functions, you see this is the asymptote, -1. It's in the equation itself. Here for the reciprocal function, this is the asymptote. Okay,
Okay.
this is what y can't be for a reciprocal function. So what's the range of this? Again, it's gonna be a union thingy-majig.
Negative infinity to 8.
Yeah,
Exclusive. In union with 8 to positive infinity.
yeah, and there we go. Okay.
Mhm.
So those are kind of like the standouts. Let's do one more here, J, and then we'll call this one done. Okay, what's the transformation here? What's going on with the cosine of x? Cosine of x looks like this, the parent function.
1 plus cosine. So isn't that just cosine x plus 1, really?
Yes, it is.
Okay, so it would just be up 1 unit.
Correct,
Wouldn't it?
Edmundo. Yes, so right now it's at 1 to -1, right? So
Yeah.
that means if you go 1 unit up, it's gonna be from 2 to 0.
To negative. Oh, 2 to 0.
0.
Okay, yeah.
Add
'Cause it
1,
doesn't
add
get
1,
bigger.
right? So this is the midpoint, and then your graph is gonna look something like this,
Okay.
from 2 to 0. So again, the domain for this, the domain for every question here, actually, the domain for every question here is XER,
Yeah. Okay.
but the range is different. For 1 plus cosine of x, what will be the range?
This would be 0 to 2. Exclusive.
Not exclusive, inclusive. Exclusive is
Oh,
this
sorry.
guy and the
Right.
logistical
It can't
function.
touch that. Yeah.
Yeah.
Sorry.
Okay, we're done with that, right?
Mhm.
All right, let's do domain. Are we gonna finish this? I mean, I guess we could, right? There's what, 60 of them? We don't have to do these extending ones, I think.
Yeah, and there's no like justification or like those sorts of problems in the test, so we can avoid those as well. Like justify this or
Mhm. We kind of did this last time, I believe. I guess we can review it. It says find the domain and range. I think we did a couple of them here from here. I can just kind of rush through
execute.
it. Yeah, execute. What's the domain and range of that?
That would be negative to positive infinity.
Yeah, what about the range?
How does this graph look, or how does this look like?
Like this.
The range would be negative to positive again.
Yeah, so just remember that that's x cubed. So any odd degree function, even if they ask you x5 or x99, is the exact same thing as x, the domain and range. Negative infinity to the positive infinity, both of them, xer, yer. Okay,
Got it. Mhm.
well, let's look at 13. So that's a quadratic. We know the domain is simple. The domain for both of these, or all three of these, is xer. That's easy. But let's look at 13. How do we find the range of this?
Set the equation to 0. Or
That's not how you find range. You can't set it to 0. If you set it to 0 and solve for it, you could man it, I guess. That'll give you the x-intercepts. That won't give you the range.
um
You need to find the vertex.
oh yeah, what was the 2b or negative
Yeah,
b
yeah,
over
exactly.
2?
So you need to find h and k, okay? So h is minus b over 2a.
To find y-intercepts of quadratic.
Not
You have to use
y-intercept.
that.
Y-intercept is given right here, plus 1. The vertex.
Or sorry, vertex.
Okay, h is minus b over 2a. What's b? Minus b. What would that be here?
Minus b would be negative 2.
Exactly. And 2 times 1. So our h is minus 1. Okay. And to find k, you just plug in the h value back into the equation.
To find k. And k is just stretch or compression.
No, no, no. K is the vertical shift. H is the horizontal shift. K is the vertical shift.
Okay. H equals horizontal. Okay.
So I got h as -1, and then I got k as 0. So the vertex is at -1 and 0.
So you plug h back into the equation as x.
Yes, and that will give you k.
Yep.
And is this parabola opening up or down?
It would be opening up.
Yeah. So the vertex is at -1 and 0. Okay, see that, right? There's the vertex, and the y-intercept is 1. So the sketch looks like this.
Yeah. Okay.
So now what would be the range?
0 to positive infinity.
Good. So here's a quick tip for you. Range, the only thing that affects the domain and range is reflections and shifts. Shifts means translations, like left, right, up, and down. Like stretches, you see this 3 on the outside. Stretches and
Yeah.
compressions don't do anything to domain and range. This do not affect the domain and range, stretches and compressions.
Okay.
So here, 3 root x plus 8, we know that, what's the domain of this? Super simple.
Through this would just be 8. It would be 8 to positive infinity, or sorry, negative to positive infinity, and the range would be 8 to positive infinity.
Exactly. That's easy. Okay, let's look at 17. So now that's called a rational function. This is not a reciprocal. If you have x's on both the numerator and the denominator, that is called a rational function.
Mm-hmm.
Now let's look at this. We're gonna try and
What does
cancel.
that look like? What does that look like?
Probably something like this. It's gonna end up becoming a reciprocal because the x is gonna cancel out.
Okay.
So it's gonna look like this. What can we take out from the denominator here?
You can take out x.
Yeah, we can take out an x, and what are we left with?
We're left with x minus 2.
Yeah, x minus 2, right? So we know for the domain, right? For the domain, the denominator cannot be 0. Yeah?
Yeah, yeah.
Numerator can be 0, but the denominator can't be 0. So we're going to set this equal to 0. So what is x equals to? If x times x minus 2 is 0, what is x equals to?
X times x minus 2 equals 0. 1, 2.
So you have to set this equal to 0. So one of them is 0. And then you set this bracket equal to 0, x equals to. There's 2 zeros here, 0 and 2. There's
Yeah.
2 x-intercepts. So what does this mean? This means domain is it cannot be 0, neither 0 nor 2.
Okay.
Okay. In fact, if you notice here, see this x cancels out with this, right? And we know x is 0.
Mm-hmm.
Yeah.
Yep.
So that means at x equals 0, there's a hole in the graph.
Okay. So that would be where they part, like
Yeah.
reciprocals part. Okay.
Yeah. And if x were to be 0, what would be the y value?
X was 0 would be the y value. 2.
You'll have a 0 over a 0, no?
Yeah.
So that means y cannot be 0, because 0 over 0 is undefined.
Okay. And how, like, explain to me how you try to find the y value though. How would you find the y value there?
How would you find it?
Yeah.
I just plugged x in there, okay, and that gave me a 0 over a 0 in the numerator, right?
Mm-hmm.
That means y cannot be 0.
Oh, you just, okay, sorry. You just plugged it back in.
Yeah.
My bad. Okay.
So the domain is going to be -infinity, 0, 0 to 2, 2 to positive infinity. Is it inclusive or exclusive for the domain?
Domain would be exclusive.
Good.
Because they're asking.
Yeah, exactly. They would be exclusive. And for the thingamajig, y can't be 0. So -infinity to 0, 0 to positive infinity on the range. Okay.
Yeah. Okay. Yeah.
Let's just do we can just quickly do this. 12 is super simple, linear, XER, YER, not concerned with that. 14, the domain is XCR, quadratic, right?
Mhm.
If you notice, 14 is in the vertex form. So what's going to be its domain and its range? Sorry, domain is XCR. It's in the vertex form. What's going to be its range?
Its range. Okay. It goes 2 units to the right and up 5 units, which means it'll be 5 to positive infinity.
Yeah, good. Let's look at 16. So now 16 is a square root function. Yeah.
Mhm.
So in a square root function,
Can't have a 0.
it has to be greater than 0. You can't have exactly 0, but it has to be greater than 0. What does
Yeah.
that mean? That means this bracket, right, has to be greater than 0. Or
Yep.
equal to, greater than or equal to 0.
Wait, it can be equal to 0?
Yeah, the square root of 0 is a 0. Not in the
Oh,
denominator.
right.
In the numerator, it can be 0, yes. And now we're just going to solve this equation. Okay, just treat this sign as an equals to sign. Step 1, add x squared on both sides. Yeah.
Mhm.
And now what would x be?
X would just be 2.
No, plus minus.
Plus minus 2. Sorry.
So what does this mean? This means x has to be between plus and minus 2.
Plus minus 2. Okay.
So the domain is -2 to +2 inclusive, because if it's exactly 2, it's going to be it's going to be 0.
And this one, there's a reciprocal function, right?
18?
Yeah.
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 But we're doing, this one is for 16 though.
Oh, sorry. Yeah, that was for 16. Yeah, so that's just radical.
Yeah.
Okay.
Now again, 18 is very similar, except here 16. Oh, see, this is a radical function. We have not really done anything in the y-axis except it's flipped. You see the minus
Mhm.
sign? So
Yeah.
this is the same thing as a parent function, but it's flipped upside down. So the range would be from 0 to -infinity or -infinity to 0, inclusive.
Okay.
Let's go to 18. Now the domain, that thing
Wait,
in this,
wouldn't it drop below 0 though?
no, it wouldn't.
Because it's range.
Yeah, range, we're
Wait,
not, we
what?
see, the only thing that's happened here, this is for the domain, okay?
Mhm.
The only thing affecting the range is a minus sign on the outside. That means it's gonna flip upside down.
Okay.
So before the
Oh,
range
yeah.
is 0 to +infinity, now it's gonna be from -infinity to 0.
So now you're using the x-intercept almost as your y-intercept, right?
Yeah.
Okay. All right.
Let's look at 18. Now again, that's a radical. You can't have a negative inside a radical, but since it's in the denominator, we also cannot have
Can't have
a 0.
0.
So it has to be strictly greater than 0.
Mhm.
Okay. Now how do we solve this for x?
We put an x squared on either side.
Yes. So 9 minus x squared is 0, and then 9 is x squared. That means plus minus 3 is x. Yeah.
Yep.
So this means x is going to be strictly between -3 to +3. Inclusive or exclusive?
It's exclusive.
Exactly, because if it's inclusive, you get a 0 in the denominator. In this question, it was inclusive because it's in the numerator. It can be 0.
Mhm.
But in this question, since it's a rational function, it cannot be 0. So it's strictly exclusive.
Mhm.
Now let's look at the range of this function.
Okay. The range. It goes 9 units to the right.
So for the range for these types of functions, again, all right, what you need to understand is this is for the domain. Everything inside the function is for domain. Okay.
Yeah. Okay. Okay.
Now you're going to compare this to the parent function. Did we do anything to the range? No, we didn't.
No.
See, here we flipped it, but here we didn't do anything. So the range for this is the exact same thing as the range for the parent function.
So it'd be -infinity to 0 and union with 0 to +infinity.
Yeah.
Yeah. And it's exclusive too, right?
It's exclusive.
Or
Yes.
no.
Yes, it is
Yeah.
exclusive.
Okay.
All right.
Mhm.
There's a lot of questions. We did this question last time. I don't know if you remember. Removable discontinuity is when there's a hole in the graph. Like, what does that mean? If you have something like this, x squared over x plus 2x, something like this, yeah?
Yeah,
So that means, what can we pull out in the denominator?
can pull out X.
Yes. And now what am I left with? X plus 2, right?
Yep.
You see, this is going to cancel out with this, right?
Mhm.
And then we're left with 1 over x plus 2. So what this
Okay.
means is that at x equals 0, yeah?
Yep.
This is one of the, well, it would have been one of the asymptotes. At x equals 0, since the numerator canceled out with the denominator, there's a hole in the graph. And that is a removable discontinuity. Hole in the graph
Okay,
is a removable.
what's an unremovable one? Can you give me an
This
example
one,
of
the
that?
asymptote. So at x equals 0, there's a removable discontinuity, but at x equals -2, there's a non-removable.
A hole equals removable, right?
Yeah.
And then X at -2. Oh, because that would give you
An
a,
asymptote.
that would give you a 0 in the denominator as well, right?
Yes, yes. And there's nothing to cancel that with. So that's going to be an asymptote, which means it's a non-removable discontinuity.
Oh, so basically whatever you're left with when you cancel them out is non-removable.
Yes.
Okay.
So that's done. I think we've done some of these questions. Let's actually do some things that we have not done. I'm going to start upside down. Okay, so this is going to be 1.6. I'm going to jump because of time, because we did most of those domain range questions last time as well. So here it says, if f of x is this and g of f is this, find an expression for fog of x and give its domain. Alrighty.
Oh yeah, that's f of g. Yeah.
Yeah, exactly. So for a, that means the fog of x just means f of g of x, right?
Mm-hmm.
So what's the next step?
So g of x. The next step is to plug in g where f of x is found.
Yeah. So it's going to be f of what?
F of g of x.
So yeah, just replace the g of x with what it is. So x squared minus 4.
Yeah, so x squared minus 2. Okay.
And now what's f of x squared minus 4?
F of x squared minus 4. Would that just be x minus 2?
No, we're not. We're not trying to solve this. What would this be equal? So again, how did we do this part? F of g of x, you see,
You plugged in g.
Yeah, exactly. We're gonna do the same thing here. F of x is this. F of 1 would be the square root of 1. Yeah.
Yeah, so it would be square root of x squared minus 4.
Perfect. There we go. This is what f of g of x is. And now this is only asking us for the domain. By the way, the range is going to be from 0 to infinity. How do I know that so quickly? Because see, we've done nothing outside the function. Everything inside the function only affects the radical function, only affects the domain.
Oh yeah, she gave us steps to find the wait, what did she? Oh yeah, take the domain of the input only, and then the domain of the entire composition, and then you can take where they intersect. I don't know. That's what she said.
Okay.
Does that make sense?
Kind of does. I'm going to do this in a way that we did the previous question, where again, see, this is a square root function. Yeah.
Yeah.
And then a square root function has to be greater than or equal to 0. So I'm just going to plug this entire thing as greater than or equal to 0.
Mm-hmm.
What you just said, I think that's for dividing.
Yeah, maybe.
Anyways, I think you understand this one. Right? It's very simple. You don't need to remember any rules. Just remember that in a square root function, it has to be greater than or equal to 0. Yeah.
Yeah.
How do we solve for x?
We put x squared on both sides.
Yeah. And then we'd add a 4 on both sides, right?
Yeah.
So what that means, what is x greater than or equal to?
2.
Yeah, exactly. Plus minus 2 though.
Yeah.
Okay, so now you just have to be a little bit careful. Okay, once you have these numbers, can x be 3?
It no.
Yes, it can. If x is 3, you get 9 minus 4 square root of 5. Yeah?
Okay.
If x is 3 here, you get 9 minus
Yeah.
4 and square root of 5 is 2 point something. It's a positive number, it exists. So we're cool with going to the right-hand side of 2. This one is in the domain, okay? When x is exactly 2, you get a 0. That's also in the domain. That's fine. Now let's go on the other side at negative 2. Can x be negative 1?
No.
No, it cannot be. Can x be negative 3?
No.
Yes, it can. Here, look at this. Negative 3. Again, just plug it in. When in doubt, just plug it in. Negative 3 squared minus 4, you get negative 5. Oh, sorry, square root of positive 5. So that means to the left of negative 2, that is also in the domain.
Okay.
Do you see this?
Yeah. Yeah.
So what's the domain of this function? Just look at this number chart.
The domain is
By the way, there's closed circles here. Closed circles, that means it's inclusive. Because when x is 2, it's 0. That's fine.
so wouldn't it just be negative 2 or sorry, negative infinity to negative 2 in union with 2 to positive infinity.
Yeah, exactly. And both inclusive at the numbers, okay?
Yeah.
Because
Wait,
when x
I'm just
is,
confused.
yeah.
I'm confused. Like I've never seen this process. So like before you introduced it to me. So this is how you find like
The domain.
okay. The common domain of like the new function,
Yeah,
right?
yeah, exactly. Yeah, yeah. The combined domain, basically.
Okay. You mind if I take a photo of this or like
No, I'm recording it anyways. Yeah, you can take a picture.
yeah. All right.
Okay, let's do gof of x. I'm just calling that an O, but it's not really an O, right?
Mm-hmm.
That just means it's g of f of x.
Yeah, could I try this one?
Yeah, go ahead.
And then okay. So golf of x. And give it a isn't this the same question?
No, it's
54?
not. It's flipped. It's flipped.
Oh, okay. So now we plug in f where there's g.
Yeah.
So
Yeah.
it would be square root of x squared minus 4. Right?
That's what we had in the last question. No, you did the other way around here. Look at this. G of f of x. We first attack the bracket, okay? So g on the outside stays where it is.
And
now
then there's
you
brackets. Oh, okay.
yeah, replace f of x with what? What goes here?
Root of x.
Yeah, there we go. And now we plug the root of x in here as x, because that's what g is.
Okay.
So what does that give?
X squared. Okay, bracket.
Okay,
Yeah,
square root of
that's
x
what I was
squared.
trying to say. I just said it weirdly. I don't know. Okay.
And now what does this simplify to?
Doesn't that just simplify to x minus 4?
X squared minus, oh yeah, exactly, x minus 4, not x squared. The square root cancels out with this guy, right? So you get x minus 4.
Mm-hmm.
Now for this, it's a linear function. The domain is super simple.
Okay. The domain, it goes, isn't it just negative to positive infinity?
Yeah.
And then the same thing for the range.
Yeah.
So, okay, but okay, I understand everything except how you combined the equation, like g of s. So you had in brackets as g bracket square root of x, but then from there, how did you go from that to? Did you actually multiply them? Like,
No, I didn't. Again, here, step by step. G of f of x, right? So the thing on the outside stays outside until you attack the function inside. Okay, I didn't multiply anything. Now you see f of x, I'm gonna replace this with what it is. What's f of x? That's the square root of x. So now you get g of square root of x.
okay.
Okay, that's step one. Step two, now look at this. G of x is x squared minus 4. What is g of 1?
Wouldn't it just be 1 squared minus 4?
So what would g of x squared, g of x be? Square root of x.
1 squared minus 4. Okay.
So g of square root of x would be square root of x, square root of x minus 4. Square root of x squared minus 4.
Yeah, square root.
You replace this x with what's in the bracket. Okay.
Okay. Yeah.
So that means we get x minus 4. Actually, we forgot something in the previous question. So we deduced that was -2 and negative infinity to -2, yeah. And then from 2 to positive infinity, this was the combined domain for A, right? Inclusive. But now notice, okay, I didn't do the last step in A. This is for 53. Negative infinity to -2 is not in the domain of f of x. You see that f of x is from 0 to positive infinity on the domain. Yeah?
Yeah.
So this is what your teacher was talking about. This, where do they intersect? They intersect right here. So this is the answer to A, not the union, because this is not in the domain of this.
Oh, it's only where they overlap.
Yeah, exactly.
So then you have to consider the original
Yes.
overlapping of the parent functions.
Yes. So this is the answer to part A. Let's look at the answer to part B. So for this function, it's XCR. The combined function has a domain of negative infinity to positive infinity, right? What about the first two? Where do they overlap with this?
Okay, the first two. The first one is just negative infinity to positive infinity for domain.
No, 0. So radical cannot have a negative number. It's from 0 inclusive to positive infinity. Right?
Okay, sorry, yeah. Sorry, 0. And then it's 0 to
positive
infinity.
So now where do they intersect? This one is for XCR as well. Now where do they overlap?
0 to positive infinity.
That's the answer.
Okay.
So this is the domain of g of f of x.
So could you not just could you not just look at the individual domains and then just see where they overlap?
Yeah, that's what we're doing. Yeah. But you need to also find the no, you also need to take into account the domain of this. Because the individual domains, they're always gonna overlap between the 0 to positive infinity, yeah? This is the individual domain overlap, but if you look at the previous question, the answer is 2 to positive infinity. So it's not where only they interlap with the combined function, or where the combined function interlaps with the individual domains.
Okay.
Okay, let's do 55. Fg of x, that just means you multiply f and g together. Fg of x just means f of x times g of x.
Okay, so this would just be root of x times x squared minus 4.
Yeah. So what does that give you? That just gives you x squared root of x minus 4 root of x.
Yeah.
So what could be the domain here?
The domain.
Again, x cannot be, see there's a square root, that means x cannot be negative. It has to be 0 or bigger.
Yeah, so 0 to positive infinity.
Exactly. And the intersection is right here. This is the answer, because if you look at the individuals, this is XCR, this is 0 to positive infinity, so they intersect what the domain of this is basically. The domain of this and this is the exact same.
And then find the expression for f over g of x. Give it this domain. This one would be root x over x squared minus 4.
Yeah.
How do I do this? You can't have a 2 in the denominator.
Again, plus minus 2. You can't have
Plus minus 2, sorry.
And that's it. That's the domain. You don't have to take into account the overlap for these questions. Only for these questions you take into
Wait,
account.
why would it be plus minus for this one though? It's not under square root.
Because minus 2 is also positive. So what are you trying to do? You're trying to do this. X squared minus 4 cannot be 0, yeah? So x squared cannot be 4, and then again, square root both sides, x cannot be plus minus 2.
Oh, because it could also be, it could
Yeah.
be either -2 or +2.
Yeah, that'll
to
give
get
you a
the same.
positive 4 here, and that'll give you a 0 in the denominator. So it's going to be negative infinity to negative 2 exclusive, because if it's negative 2, you get a 0 in the denominator. Union, negative 2 to positive infinity. So you don't have to check the overlaps if it's like question like 55, 56. Only here you check for overlaps.
So only when it's f of something.
Yeah, yeah.
Or g of something.
Yes.
Okay.
We can quickly do 57 and I guess our 58. Let's do 58. That's a little bit more difficult. They're the same questions. So 58, what was f of g of x? That was the square root of x squared minus 4, yeah? First question here.
Yeah.
So this is for 58, f of g of x. Now it's asking you for the n behaviors, right? It's
What does that mean? Like minimum or local minimum?
No. It means as x is going to negative infinity, where's y going? Yeah.
Okay. So for this one, what's the parent function?
Square root of x.
Root of x. Okay. So it would be going up.
Well, you have to say whether it's going to positive infinity or negative infinity.
I would say positive infinity.
So when x is going to positive infinity, right? As x is gonna getting bigger and bigger and bigger, y also gets bigger and bigger and bigger.
Okay.
So on this side, right? That's fine. Okay.
So one behavior as x increases, what does y do?
So now again, just plug a very big number in here. Like let's plug negative 10,000 in there. Yeah.
Yeah.
That's still gonna give us a positive number. So what does this mean? This means this graph, right? We know the domain, actually, we deduced it for this one strictly. It's gonna look like this, right? Negative 2, it's going that way, from 2, it's going this way. So this means, see, it's increasing on the left side as well.
Oh, you have to account for both sides. For the
Yeah,
plus
exactly.
Minus, right?
So on both sides, as the x is going up and up, y is also going up and up.
So if plus minus account for both sides.
Okay, that's how you do n behaviors. You always write this line as x goes to negative infinity and x goes to positive infinity every time you see the n behavior words. And then these answers will be different depending on what graphs or functions you have.
Right. Okay.
Let's do this one. So this is kind of like a transformation question and a bunch of different questions thrown into one. Let's look at 45. It says, sketch the graph of this, okay? So what does the -1 on the outside do?
Down 1 unit.
Yeah, exactly. So all you do is take every point and then just throw it down 1 unit. So like
Pretty
this
easy.
on the quadratic. Yeah, this is, I think you can do this, right?
Yeah.
So it looks something like that. Throw everything down. What about B? 46. What does that do? -1 on the inside.
To the right.
Yeah, so just take everything to the right by 1 unit. So it's probably gonna look
Mhm.
like this. Yeah.
Yeah.
What about 47?
Vertical reflection.
Yeah, so it's a reflection on the y-axis, right? So you'd flip this, put a mirror right there. For 47, put a mirror right on the vertical axis. So this part is gonna come there. This part is gonna come there. And then the straight line is gonna go down there at 3. There we go.
Yep.
What about 48? The minus is outside the function.
Over x-axis.
Exactly, right? So you know how to do this. So this 2 is gonna become here. Instead of this going this way, it's gonna go down. Instead of it going like this, it's gonna go like this, and then like that. Again, you can
Yep.
just find a couple of points to do this very precisely. 49, sketch a graph of the inverse function. A relation, it
Okay.
says.
The inverse function. So the function just f of x.
You have to do
Or-
this graphically. There's no way to algebraically do this. Not yet.
Oh,
anyways.
so you flip over the that line you were talking about. I can't remember what word you said.
Or you can just flip over the individual points. Okay, that's also inverse. Inverse is xy becomes yx. So we can just take a
Okay.
few points and just flip them literally. See, this point is 0, 2. So this point is gonna flip to 2, 0.
Yeah.
Okay. This point is what? This point is -1 and 2. So that's gonna flip to 2 and -1.
Mhm.
Or you can just, I'm just gonna, you can be precise like that, okay?
Yep.
And then what is this point?
That is -3 and 1.
Yeah.
So it'd be
-3 and 0. This one -3 and 0. So it's gonna become
sorry,
0,
-3 and
-3.
0,
Yeah. And then this one is 2, 4. It's gonna become 4, 2. Up there is 4, right?
Mhm.
Like that. And then just to connect the dots.
Yep.
And I see it looks like a reflection about this.
Mhm.
Does the inverse relation define y as a function of x?
Yeah.
Actually, it does not. You can just do the horizontal line test on the main function.
Oh, yeah.
See, it touches it twice, horizontal line test. So 50, no. 51, sketch the graph of y equals to the absolute value of f of x.
Is this restrictions on the x then? Only
No.
y values.
Yeah, so what this means is you can't have negative y values. Y values must be positive. No restriction on the x. Only restriction is y values must be positive. So if they're not positive, make them positive. What does that mean? So up until here, we're fine. All the y values are positive. Yeah.
Mhm.
From here, the y values are negative. So all we're going to do is reflect it on the horizontal. And we're done.
That's pretty easy.
Yeah, it is. So here's a more complicated question. So now let's say this is the same thing and they're asking us f of, the absolute value of f of x. Okay,
Mhm.
the absolute
Mhm.
value of f of x. All you need to do is to flip the parts that are negative. So up until here, we're good. From here to here, you have some y values. So we're just gonna flip it upside down.
Mhm.
From here to here, we're good. All the y values, and here it's going down. So we just flip that and there we go. This is the answer. You cannot have negative y values. Okay. F, determine this as a piecewise function. 52.
It's a piecewise function. And the pieces of transition to. Okay, the first one is just linear, so wouldn't it just be from -infinity to -1?
Yeah, what's a linear function?
Just x.
No,
And
it's
then
not
it does.
x. It's not x. It's x minus 3. Or actually, does
Oh
that
yeah.
work? I don't think it's x minus 3. So we can just find it. Well, the second one is x squared plus 1, right? Yeah. This one is
Yeah,
x squared plus 1. So that's from -1 to positive infinity. Now, what is this linear function?
Wouldn't it intersects with the 3? It looks like
Yeah, so exactly. So that's going to be x plus 3.
x with 3. Yeah.
And that's up until negative infinity to -1, and looks like it's inclusive. And then the next one is actually they both can't be inclusive. One of them has to be exclusive. So I'm just gonna say the
Mhm.
linear is exclusive.
Yeah.
Okay, and we're done.
Yeah, that makes sense to me. I get that. Is that are we done the review? That's good.
You think so? No, let's do a few more. Don't worry. We
Okay.
have some time. We're gonna find the inverse for these functions.
Perfect.
So again, step 1, see this is your y, okay? This is your y. We're gonna flip the y with the x. So what does this equation look like? It's gonna look like x equals the cube root of y minus 8. And this is our f inverse of x.
Yeah.
We need to solve this equation for y. The answer will be in terms of x. How do we do it?
Okay. You have to take the cube root of 3, don't you?
No.
Or sorry, cube root of x.
Nope. You have to
I
cube
don't know
both
how to
sides. Cube both sides, not the cube. It's
cube
already
both
cubed.
sides. Sorry.
Yeah.
Okay.
So x cubed is equals to y minus 8, and just add an 8. So therefore, f inverse of x is x cubed plus 8 for 42. Easy.
You add an 8. Okay. Yeah, that's pretty easy.
Okay, let's do the next one as well. So all you have to do is flip the x and the y.
Okay.
So what's
So
the
this
first step?
one would be 6 over y plus 4
Yeah,
equals x.
perfect.
And then you would just
When you solve for this,
you would multiply by y plus 4.
yeah, good. Yes, actually, you do exactly that, because we need to get this out of the denominator. And then what do we do?
Okay.
Do not open this bracket. Divide both sides by x.
Okay. So then you get 6 over x
Yeah, and then
equals y plus 4. And then what would you do here?
just subtract 4.
Subtract 4.
You're done. One
Because
and
you
done.
want it in terms of x. Yeah.
Yeah, and one and done. There you
Okay.
go. That's your y inverse. Right? Easy. Right?
Yeah.
You get that?
Mhm.
We can just quickly do this as well. I'm going to show you how something is even or odd.
Yeah, I need to know this.
So we can just do these two. So again, odd is this. If you have f minus x, you get minus f of x. This is odd. Even as if you have f minus x and the negative sign completely disappears. This is even. And if it's not neither, it's neither.
Okay.
Okay, let's do 38. So if that's f of x, what's f minus x equals to?
Sine of negative x
Yeah.
minus x cubed.
Perfect. Now this is just something you have to know. Sine of negative x is a negative sine x. So sine of minus x is minus sine of x, and cosine of minus x is minus cosine. Or sorry, it's an even function, so it's positive. So when you put a negative inside the sine, it comes outside. When you put a negative inside the cos, it disappears.
Here, I gotta write that down. So sine of negative x equals negative sine x, but cos with negative x equals cos x. Okay. And then from there,
So sine of negative x
just become-
became this, right? And then this is going to become negative x cubed, so positive x cubed.
Yeah.
And then you can take out a negative sign, or sorry, negative sign, not the sign function, but just this negative. And then you're left with this inside the bracket, okay?
Yep.
And see, this is the
just
exact same thing that we started off with.
So that'd be even.
Odd.
Oh, that would be odd.
Yeah. See, the negative sign came outside the bracket. Where you had negative sign inside f of negative x, and see, it came outside. So that is odd.
Oh, okay.
40 is probably even. Let's try that. Actually, 40 is neither. I'll show you why. So again, what would f of negative x be for 40?
40. Okay, that would be that would just be cos x minus or times minus x.
Oh yeah, so cos of minus x, negative x times
It's
cos
just,
of minus
it's just
x. Yeah?
cos x.
Yeah, exactly. This is cos x, but negative x is just negative x. Yeah.
Yeah.
So this is basically negative f of x. See, f of x was x cos x, and now we got negative x cos x. So this is also odd.
Okay. So it's just -1 times the equation. Really.
Yeah, yeah. But if it was x squared, right? If it was x squared, then this would be even. Here, look at this. X squared, and negative x squared is just positive x squared, right?
Mhm.
And see, we get the exact same thing that we started off with. Positive x squared cos x squared cos x. So that is f of x, and that is even.
Got it. Yeah, I understand that.
Alrighty, then I think you should be fine. Domain range transformations and these guys.
Yeah.
And we've done most of these last time as well. I remember this. Okay.
Mhm. Yep.
Alrighty, then you should be good, man. I think. I hope.
Yeah, I hope I do well.
How'd you do on
All
the
right.
last one?
I got a 90, but it's weighted differently because it's honors. So
Oh, okay.